Hi, everyone. Welcome to another Common Lisp study group. I'm your host, Ron Vadum with Atlanta Functional Programming. I hope all of you had a great Christmas holiday and a New Year's. This is our first episode of the new year. Today, we're going to be discussing or continuing our discussion on the cl-neo4j library, particularly with some of the issues that we saw a couple of weeks ago. To recap, for those of you who are just joining in and may not have seen last week, the episode's now 2 weeks old. What happened was there was a couple of issues that we've encountered, particularly with the cl-neo4j community library, and it was pertaining to the RESTful API that was being provided by the cl-neo4j community bullseye image that I found on Docker Hub. So I started doing some digging after our discussion and episode a couple of weeks ago. And unfortunately, due to time constraint due to the Christmas holidays and as well as work, I was unable to go further than beyond a cursory look. I tried to find a specific Neo4j image that kind of went through and provided the API that was expected by the CL Neo4j library itself, so to determine whether or not we can actually leverage the Neo4j library, at least with a specific image that's available on Docker Hub. Unfortunately, um, much to my luck, I couldn't specifically find a image that would provide what I kind of wanted. So I thought today we'd go through some experimentations, at least with some of the Neo4j images, try and see if we can actually find ourselves something that would end up providing us with a very simpler library that allows us to kind of work through this this particular wrapper that was provided to us. Now, as I said before, for those of you who uh, were with us a couple of weeks ago, cl-neo4j itself has a library is has very limited documentation. So it is my kind of goal to kind of, go through at least some of the library's functions to give you at least a sense of how to leverage this particular library to do graph databases applications. Now, one thing to recognize is because of its its age, at least the library itself isn't fairly actively developed on, but it is in QuickLisp. Uh, it may be that this API that it is looking for is outdated, and we would have to go and do some kind of surgery to actually um, get some sort of uh, you know compatibility with the latest version of Neo4j. If if it turns out that is the case, from today's discussion, I think what I may end up doing for the next couple of weeks is walk us through essentially the Bolt protocol, which is a TCP protocol that Neo4j built specifically to communicate with um, Neo4j on the TCP side without the overhead of using HTTP, and try and see if we could come up with a simple Bolt driver to at least run Cypher queries against the database. So this is kind of the plan of attack that I'm going to kind of walk through with today. Now, this the purposes of these couple of streams is mainly to encourage um, the folks and my fellow viewers that in some cases, especially for external services that you may end up wanting to use, Common Lisp, because it doesn't necessarily have the support, may require you to actually go in and look into the documentation and build up something. But at the end of it, you'll end up probably having a library that you could share with the rest of the community, and you can end up documenting some of this stuff. And I'm hoping through this small project, as we, work our way through creating something that will allow us to leverage the graph database, we'll end up with something that not only is usable, but it's Lispy enough for us to, compose and leverage it like any other Lisp library as it stands today. As usual, before I start our code deep dive, I would like to make a couple of announcements. One is Atlanta Functional Programming is looking for speakers. So for those of you who are watching and are interested with a particular topic, anything functional programming related in any language, um, and even software architecture discussions are more than welcome. uh, I encourage you to reach out to me. I'm Bugram on the Functional Programming Slack channel, as well as for those of you who are residing in Tech 404, which is Atlanta's technical Slack workspace. I'm also Bugram on that as well. So please feel free to DM me. I also squat on the Lisp Discord server for those of you who are wanting to talk about a specific Lisp-oriented topic, and I'll try and get you scheduled as soon as possible. So I thought it would be best to try a couple of images here. One of which that I was going to try is and let me go ahead and hold on, throw up eShell here for the sake of today's discussion. Let's see if I could do a Docker pull cl-neo4j just to get the latest version of the Neo4j library that we could then end up leveraging inside. And we're going to just try and see if we can actually leverage this by running. And I'm going to run this in the background for our sake. Give me just 1 second. So what I'm doing is I'm creating a new, okay, so let's do this. Let's go in and do a Docker volume rm neo4j storage for the sake of, and let's create a new one. Okay, so now what I have to do is Docker run -d. 1 second here. I have to. Okay. Sorry, I just messed that up. Docker run -d -p. We need to go and do this is just to open up the ports for both the Bolt protocol as well as the HTTP protocol, which runs on 7474 inside for inside the Docker image, and for the Bolt protocol is 7687. And we need to also provide the volume, and since we've created a storage volume inside Docker volume, we're going to just set that up to being data and then name neo4j. Let's see if that actually runs. My apologies. I forgot to say neo4j latest. Again, for folks who are looking for Docker best practices here, of course, you don't want to use neo4j latest. You want to do something a little bit more 1 second. Good. So that's all set up. Okay. Okay, so let me just quickly do one thing here, which is set it up so that we actually have an account on this. Okay. Okay. All right. And then let's do one thing here. Just make sure our credentials that we created earlier is set up. And I'm doing a lot of this in the background just because it's kind of best practice, just to kind of not show some of the credentials that are being created. All right. So this is all done. So let's get cracking. Let's do this. Let's look at, okay. One thing that we want to look at before is if we do a HTTP call, what do we actually get? So we get the Bolt being, the protocol being 7687. We get the Community Edition. And for transactions, we get DB database name TX. So this is where we were last time. So let's see if we have a database. Schema. Okay, so let's go to cl-neo4j docs here. So here, let's look at creating. Okay, so one second here. Let's do that. Okay, so based on this, let me see one thing here. Let's do so what I'm trying to check to see is if the Neo4j database is already created. By default, it should be there. No header authentication header supplied. That's right. We have to provide a authentication header. Let me do it here. Actually, I'm wondering if I still have. One second here. If I could get this. There we go. What we gotta do is let us set in drachma. Let's go back to, sorry, B slime. Make sure that hold on. I may need to start my Lisp again. And drachma. For some reason, my Emacs is giving me some trouble trying to do auto completion. Hold on. There we go. Let's see here. Let's see here. Bad request. Right. It is complaining about that is a bad request, but I need to set it up so that we can actually look at it. Right. Set off drachma header stream to being standard out, and let's see what happens here. There you go. So, there's the problem. So the problem is it's not liking the authorization stuff that we did here earlier. This is the same stuff we saw earlier. 1 second. Get rid of. This needs to be a key value pair, but this one, how did I solve this last time? This is this was because we had to use other things. Right. Okay. So what I'll do is go back to it's not additional headers. The problem is additional headers is the problem. It is authorization is not a type list. Okay. So it's not liking the let me see if I could do this. I don't think this would work, but something that we could try out. Let's see, this is also a bad request, and if we look at it, it's still treating it as a list regardless. So what if we do, okay, hold on, in drachma, additional headers, there we go. Additional header is the name of a list. Cannot only be strings, but also designated for urinary functions, which should in turn return a string. Let me try this to make sure that this actually works inside oops, not that. Try this. So we don't want the clear text password. Interesting. It says that it's invalid username and password, but I passed in. May have to provide some additional things here. Let's try this here. All right, so it looks like we're back to where we were last week. 4 were not found. You're right. Let's see here. This is get help. This is cl-neo4j query. Let me see something here. Do I get neo4j cipher query? Okay. So we have create node, create inode, user port. Host is set to what? Oops, sorry. It's not a function. This is a variable. Okay. And port is set to 7474. Okay, good. All right. So inside I'm wondering if we need to change these D4 nodes to other ones. So let me go to in the Neo4j docs. Go look at the REST API. So all of these have been removed in Neo4j4. Oh, let me see if I can get. Okay. Okay, so it looks like the reasons for our things as expected is because these need to be changed to using the newer version of the API, as I kind of suspected is the issue. So we need to change internally these get node functions to being, let's see here. Okay, so one clean way of doing this is first going to utilities. I think it's where, no, not utilities. Where is it? It was in, first goes into globals. Yeah. And let's start first creating a database here. And we're going to call this Neo4j. All right. This is necessary because of the fact that in the Neo4j RESTful API, you are looking at what's it? As we saw earlier, let me just pull this up again. Initial. Okay, so I'm gonna clear this up just so that folks don't get confused, and I myself doesn't confuse. If we do a curl on the local host, the HTTP endpoint, notice that the transaction API has been changed from the old one. If you looked at the older versions of Neo4j, nodes, relationships, properties, and all had their own kind of RESTful API. It looks like they've consolidated everything into this thing called transactions. And for us to actually do anything, we have to first create a transaction. So let's go ahead and set up cl-neo4j with this newer version and then see what we could come up with. Well, what works and what doesn't work with this newer API. All right. So in order for us to update cl-neo4j, obviously for folks who are watching this, may be suggesting that this might be something that we can create in uh, as part of a pull request. I obviously it needs to get some testing to be done. But I'm going to just show you exactly kind of what way to extend the existing library. And if you guys come up with a better API or anything, play around with by checking out the cl-neo4j project from GitHub, and see what you guys can come up with, and then let's see what works and what doesn't work. Okay, so the way I would extend this and correct this is I will first create a global inside the globals, a def var for specifying the Neo4j database, just so that it matches the transaction API that I'm going to be leveraging. And then in the utilities API, the wrapper, I believe it was. Let me see if there's anything I have to do in the utilities. Okay, nothing for oh, yes. Format DB query. This is here. We need to change this. And it would be not DB data, but rather db cl-neo4j. And host ports db postfix database resources. And this is tx. Now, granted, I could change this a little bit more for being extensible to use the global database variable that I created. But for now, we're going to just set this up so that we could first deal with creating nodes and maybe even sending up some Cypher stuff, and then work our way through cleaning this up so that this is actually updated the way we kind of think. All right. Okay. So the next thing that we're going to have to do is we would need to first open a transaction. Okay. 1 second here. I'm just looking at how the REST API does something so I could show how this might play out. REST API. This is 200 status. Okay, get. So what does this get node do? Macro expand, create a function, checks, makes the cl-neo4j request here. This is also okay. 1 second. Make neo4j request. So it looks like oops. There's send request line 40. Here we go. With the neo4j database, we would actually want to also specify the database here. Okay. Create the request handler. Make neo4j request. Here we go. Handle request handler. Handle request is a I see. So the way he sent up got it. So the way he would do it Go back to my Scratch API, which is here. And instead of using this, I use basic authorization for J. And go into this here. Oh, right, because it's I made it a function call list. Should have noticed that myself. All right. All right. Let's see how this created it. Basic. Uh-huh. Okay. Now, ideally, you'd want to actually keep base64 encoded strings. I have no idea why this isn't just taking base64 encoded strings. Okay, I think I know what the issue is. Go back to this. This is and this is even further. Okay, so this is treating this as a single password. Okay, that's the reason why. All right. If I did our clear text password here, and we're going to have to, I mean, this is a clear text password version. I mean, you can use any other password for this. But to play around with the transaction API, I just wanted to kind of be able to do this without having to do this. I got it. Do this. cl-neo4j, neo4j, oops, neo4j host, not host, user, neo4j password. There we go. Method not allowed because of the fact that we are actually trying to do a get on something that can only do a post on. Okay. All right. So this is the right API that we need to go through and deal with. All right. Okay. So since everything is dealing with transactions for right now, we're going to go and do this in two places. The first thing to understand is the transaction API or TX API actually goes through two things. One is for database querying, which requires you to pass in a cipher query. That's actually something called TX/commit. Okay. The other one is actually running a proper transaction to provide you to essentially create an ACID uh, query inside the Neo4j database. This is all part of because of the fact that Neo4j has a database is now ACID compliant. In earlier versions, it wasn't 100% ACID compliance, which is why the APIs kind of changed. Um, it matured since the last time I kind of took a look at this. So obviously, this is going to be some new stuff that I would have to go through and understand. But um, let's try and just do a couple of query stuff first, which is basically dealing with just tx/commit. All right. So if I went in and changed this guide that I did here, we're going to first mimic what we're going to be doing with the Drachma request and then work our way through actually doing what's needed. Okay, method not allowed, obviously, because we have the post. So let's see here. I wanted to do a post to method post. I think is what it is. No, hold on 1 second. Drachma. Hmm. Ah, right. Here we do this. After unsupported media type. Excellent. Okay, so this is what we kind of want to do. So our goal is to essentially create to update the cl-neo4j API essentially to follow this kind of settings. So to do this, we have to first go in and look at the fact that here there's a lot of infrastructure already handled for us of creating uh, Neo4j requests, right? Now, one way of doing this is obviously is maybe updating the existing APIs, right? But some folks might end up being using those get nodes and stuff. So I'm going to create a separate set of functions for now for transactions, just for the sake of dealing with our own code and see it in another pass if we can consolidate them into a single, more uniform API that can handle multiple versions of the Neo4j HTTP APIs. Okay. Um, let's see here. So in REST API, see how we have this get function, all this at the bottom here. I'm going to add def neoj-func. Let's see, get tx node. All right, and essentially, let me actually think I need all of this stuff already. Um, the only difference is here I have to do. I believe I just have to do node ID format. Let's see here. I have to do a post commit, and then I need to create statements. Okay, so let's see how we would do this. So we're going to first create the request in our scratch buffer. Okay, and then we're going to retroactively create this tx node function and update it. Okay, and keep this old for now. All right. Let's go to our scratch buffer, which I call conveniently cl-neo4j. And then what we'll do is we're just going to create a drachma request. All right. Use the HTTP client to play around with the obvious things for us to actually set up some stuff. Okay. So, and then we're going to retroactively create a actual cl-neo4j function and extend the API for this. So to start out with is we're going to create a drachma HTTP request. All right. The API that we're going to use is what I saw earlier, which is 74 db neo4j tx commit. This is starting a new query. Although it says commit, all right, they've consolidated the querying and transaction commits to being under the same API. Personally, I think this is a little confusing. You'd probably want to be able to do nodes and properties separately like they had before. I understand the reasons behind it, because the fact that since you're going to have a query, a commit transaction, which ends up running all your queries that you're collecting up until that point, it just makes sense to have a simple single call to do some of this stuff. But from an API standpoint, it is not, unless you are thinking about it as being an instant query, commit doesn't make sense because you're not actually committing anything. You're just querying in some cases. So now we're, as we saw earlier, tx/commit only takes post and options, as we saw here in the bottom of our, if we go here, sorry, earlier, sorry, post and options. We could certainly run an options query against this just to see what it provides. So if I do options here, it'll tell you what queries, what HTTP requests it will accept. As you can see, provided here on the line here, multiple variable stuff. Now, for folks who haven't touched Drachma, just very quickly, it does do multiple value returns. The first part is obviously the string that's kind of returned from the content type. Second is the HTTP status code, obviously. This is information regarding the actual response headers that are provided to you. And then the original URI where this is coming from, and the Flexi Streams is just a stream-oriented version of this response that you've seen. And then obviously whether or not the success and failure of the request. And we could see this here versus some of the stuff that's being returned here. Okay. So we're going to create, again, a post request here, not an options. We end up having to create content type, and then we provide application JSON. Now, here, we need to also do basic authorization, which, like we saw earlier, we could just pass in our user and our password. And what it does is the behind the scenes Drachma will actually go and do base64 encoding of this so that everything gets set up as you saw inside the message format. It has to be a Lisp because that's kind of what ends up being used as inputs into the base64 encoding. Then we need to provide the payload. The payload for Drachma inside drachma is, let's see here. I'm forgetting right now. I haven't done this in a while. Posting data, blah, 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 blah. Cookie jar, blah, blah, blah. Then, okay. Now, the cl-neo4j API already provides some information to actually go in and here we go. You have to provide the content here, which is, let me see, one thing. Let's see if I can actually use, was it request? No, hold on, PB, utilities. Here we go, encode object, JSON payload. What is, okay, this is doing some interesting things that we don't necessarily need to know for right now. All right, so I'm gonna have to do this myself. Okay. First, let me just check one thing, which is in cl-neo4j, what is the JSON library it's using? Because if I need to use a different one, okay, it's using cl-json. Okay. So in here, we do content, and we do cl-json, and encode, I believe it's encode JSON to string. There we go. So what we need to do is, let's create a string. So what we're going to do is we're going to say encode JSON, and here we're going to use the reader macro for the time being, I believe is what I need. Obviously I could change this to using, might be better actually. So wait a second, I may need to change the statements here. Okay. So So I need to provide two more lines. Okay. Let me see if I can do this. Okay. And JSON, encode JSON toString, encode JSON A-list, encode JSON A-list toString. Ooh, okay, I think I could use that one. Basically, an A-list will allow me to then just pass in an associative list, do statements, and let's just say return 1. And what this is doing is just to give you what this shows you, what this does is not of type. Oh wait, associative list is wait, I think I made a P list instead of an associative list. Give me just 1 second. I have to use keywords. Yeah. Second, do this, and then create that as a list. So we have a key value pair here. Oops, not cons, cons. Okay. So if we do this, let me grab this guy. Yank. Oops. There we go. That's it. Okay, that's what I wanted. All right. All right, so this is our statement. Okay, now this is important because it looks like I may end up having to do a statement of statements based on the single return value that I've created here, but we will see if I need to do that. We'll see if it gets pissed. Well, it probably will get pissed off because it's using a. Okay. So this JSON may not be completely correct just because of the fact that I'm trying to extract what the JSON object requires, and statements basically means providing one or more cipher statements that needs to be passed over to the commit transaction. Okay, so here what we're doing is return 1 is basically nothing more than something that will, naturally just return 1 from the query engine. So it doesn't do anything spectacular, but it does give you an indication of how the actual payload kind of looks like for the HTTP request that we need to accomplish. So let's see what happens here. Okay, unsupported media type. What is the unsupported media type piece? It is, did I forget to, content type, hold on. Why is it unsupported? I used JSON. That's not correct. It did not even change the content type. Let's see here. Why didn't Drachma change that to? In here, it looks like one second. Think it's not liking the way content is being provided here. The request is wrong. Result. Content, if not nil, is used as a request body. Parameters is ignored. Context can be a string. Oh, got it. Do toString. There we go. Okay. So you have to convert the payload to a string in order for that to work. Now, what exactly did this return? You see, we're not going to get all of it just because we haven't actually ran it here. Here is what is actually returned. Okay. Now, this does not need to make sense for folks right now because this is basically the flexi stream representation of the response. Okay. I will show you at a later point in time as we move over to using creation of cl-neo4j stuff over how to actually update this. But we now have the basic structure of the actual payload that we need to actually create. Okay, so let's break this down to understand what exactly is leveraged. All right. Number one, what is the meaning of this guy? Okay. So as I mentioned earlier, the TX commit allows you to do instantaneous queries along with commit transaction queries. And like I said, mentioned that the queries itself may require you to, in some cases, start a transaction, which I will show you when we actually implement like transaction stuff as part of this graph database exploration. But in addition to that, if you're trying to do a TX commit, it will essentially do what ACID expects you to do. It says, okay, you've created one or more queries that you want to go run. Now you're committing the transaction. Go ahead and throw everything up into the query engine and allow it to run the query planner to execute each of these individual things. Okay. In the case of what we're trying to do is we're trying to run interactive queries. So the commit REST API in this case is doing nothing more than essentially run this query. All right. Now, what queries are we talking about is probably an important thing. Some of you who may not have touched Neo4j before, I was mentioning Cypher before, and I didn't actually really explain what Cypher is, kind of with the assumption that some folks may have already known what that language is about. But I will briefly explain what Cipher is about here, and even show you some examples by probably switching over to the um, web interface for Neo4j, just so that we can actually run a couple of queries ourselves. Okay, and this is important because as you learn and create nodes and all this kind of stuff, it it helps to have an understanding of what exactly is Neo4j doing. Okay, and so Um, Neo4j allows you to essentially create nodes, relationships, and properties through the Cipher API. And when you are creating a database through it, it ends up taking nodes and allows you to provide essentially information that um, that can be used to create these nodes and relationships to create essentially a visual representation of this. Cypher is a pretty simple language to use. I can show you some examples of this. This is probably the simplest example, um, and that is a simple node relationship. Um, Example coming from the actual tutorial on Neo4j. When you run Community Edition, you'll end up encountering this, um, which I encourage most of you to try. So this is what a Cypher query looks like. All right. In this case here is what we are saying is create a new relationship node. Okay. And the first node that you've created is this node called database. Okay. This may already exist for you just because when you start Neo4j community, it creates that database for you. If you have more than one database, you can certainly generate more than one database by setting up this database node, and it will go and encounter the information about that. All right. But once this node exists, you can literally create relationships by creating this arrow syntax and provide metadata information on top of the arrow syntax. In this case, what we're doing is we are we are creating a property called r colon um, says, and where that's a namespace relationship that is provided by Neo4j, and it will return a uh, a node that contains a message node that again has been namespaced message. Okay, and that is containing some metadata information inside that says hello world. Okay, so that's how you read this particular query. Okay, return queries, what they end up doing is they work a little different. Um, they are nothing more than uh, okay, based on this database that you've created, um, find the node that we have, find the message that we have, whatever that satisfies this query. Let's just go ahead and return it. So in this case, when we do this and we say return database message r has been, what we're telling Neo4j is we want any relationship that contains this. Once we've created this relationship, we want you to go ahead and show us this relationship being available inside of the database. Okay, so this is just one thing that we could create, and this is another one that we could end up leveraging. So let's just quickly, before I end today's uh, discussion, because we're obviously going to require a little bit more time to actually take what we've just learned and then move it over into cl-neo4j. Um, I'm going to just quickly show you how this will how this might work in the case of this example that we were trying to create a few weeks ago. So in here, we have a node that we're trying to create called the movie. All right. And this is just a simple node that contains the following properties, all right? Title and release. These properties are associated with the properties and metadata that's inside of the given node, and you'll end up creating a new node that encounters this information. All right. Well, you'll create a new node with this information as part of properties inside of this information. That is the benefit of the property graph. Okay. So to create this, let's go ahead and create a simple function. Let's say create node. Okay. We want, let's say, our nodes to being um, uh, let's say it's going to be node name. Okay. Obviously, we could change some of this node properties. Okay. And what we'll do is we will, for the time being, go ahead and do this drachma. And this is one way of refactoring what we've just done into something that can be moved into cl-neo4j as an extension. Do this. Let's first get the actual request stuff set up. Okay, format nil, http tilde for local host. I mean for host and port. db tilde a for database name. tx commit. And let's get our configuration. We'll get this straight from the Neo4j API, which is our host, our port, our database. Doesn't look like it's showing up here. It looks like I have to create a export for that database. So for the time being, I'll go and grab it. It should be an exported symbol, but right now it's not an exported symbol. So ignore that colon right now. It's not best practice, but it's just to get something working that we could then, once we get that exported, we could certainly do so. So we've now created our URL. Again, we're going to have to say that this is going to be a post. Basic authorization needs to be set up. Let's go ahead and grab our RJ user. Oops, sorry. CL Neo4j Neo4j user and CL Neo4j password. Okay, so now we have our basic authorization. We do content type is going to be application/JSON. And for content, we need to go ahead and essentially do a couple of things. All right, this is going to be an associative list again, just because it makes things a little easier for me. I can eventually at some point make it so that we can create objects for this information and then set that all up just like we had before. And then you end up getting a new API for it. But for simplicity's sake for today's discussion, we're going to just stick with associative lists. So we do encode JSON a list to string because the payload requires a string. Okay, so we do list, we do cons statements. Now in here, we're going to do a list cons statement first, and then this is going to take essentially the information that we provide. And there's a couple of things here that we need to kind of set up that I need to still kind of work through. Um, but this is going to just go create. Let's do this. Sorry, we do a format nil create tilde a. Wait. Where is it? Open paren tilde a. I'm kind of assuming that you'll do the notation that is normally required for our for inserting a node inside of Neo4j, the namespacing stuff that it currently kind of gives you, just for simplicity's sake. And then we need to go and provide properties. The properties require you to do this, where you, and then inside the open braces, we need to provide each of the properties. So to do that, I have to do inside, this is a technique that's actually in GigaMonkeys for iterating through all of the properties. We're going to end up using that notation. It's just I am kind of forgetting that off the top of my head. It is, I believe, I could do this. If we do tilde open paren tilde close paren, and in here we need to provide each of the syntax comments, okay, that we saw earlier here. So like if you're doing name colon whatever, it should be able to just, take that and provide that to you. The easiest way to do that is we might need to actually do something a little different. I would love to actually just do this, but I know this is not going to necessarily work. But we will see if it does. So here, this is node name, and this is node properties. So let's check this out before we actually try anything here. Okay, boom. Okay, let's do the movie, and then here we need to create title movie released 2001. Let's see what happens. Perfect. So we need to do this, add that, and then do that. Let's see if that works. Very nice. So we may need to also provide also this. forgot that in here I have to do one thing. Which is tilde caret to determine if we need to actually provide the comma or not. So now we have what we need. So this will take your list, your associative list that we have earlier, and it will just generate what we're expecting. Okay, so now that's the create statement. But we also want to technically, we don't necessarily want to do return, but we may do want to make return. But this is basically the idea that we need to create. So let's see if this works. Okay, so now I do create node name the movie, and title the movie released 2001. Now, the one thing that I will say that is that's a little bit problematic is that since this is converting it all to upper characters, inside the database are going to have the same thing. But we've generated our our query. We've created this node. Can we actually see it now? Well, okay. For this, I'm going to have to share the cl-neo4j guy, and I will let's see, to run a basic query on this. Let's see. One second. Okay. So here we need to write. Okay. So let me share my screen here. Give me a second. Stop sharing. And let me quickly share the other one, which is this guy. All right. So in order for us to actually look at this, we need to actually write like match a movie. Oops, sorry. I accidentally hit enter. I have to do match a movie, return a. So this is telling me that the query, I may have not understood the return that it provided. Let's see. Content. Okay. Let me see if I could change this query just very quickly, just to see if there is. Okay, something wrong with my query. Let me go to this one. And let me just make sure that my query runs in this database. And if not, if it does, then there's an issue with our request that we've generated. Just copy this. Let me see if I could do that. And run this here. Okay. Let me see if I could just do this. Okay, so there is a bit of an issue with the query that I wrote. It may not be liking the quotations the way they are currently being generated. I would have to go and see how to correct that. Um, but again, I will have that would be for another time as we start organizing this through. But we're making progress on our exploration of this database. So I will stop the episode here. Tune in next week where we continue our exploration here and try to see if we can update cl-neo4j to leverage what we just learned with the transaction API, and hopefully we could start then getting down to the business of also writing some basic applications that will interact with this. So I leave it to the floor for any questions and comments. And if you guys like what you're seeing, feel free to please like the video. And I'm open to hearing suggestions. Write your comments on each video for suggestions for upcoming video topics and suggestions. And I'll be responding to them accordingly. Any questions? Okay. Well, I will see you guys next week. I appreciate those of you who joined me on the Jitsi call. And let's continue going. Thanks.